Next will be a joint presentation by Flavio Fernández and Debasish Patra. First, I'll introduce Flavio, Managing Director, DigSILENT Germany. He has been with the company since 2003 and has varied work experience. In his current position, he is responsible for power system consulting, application engineering, marketing, and sales support. Among other activities, he is responsible for the coordination of the PF technical support, the coordination of local and international training programs, workshops, and exhibitions, and DigSILENT's Power System Consultants team in Germany. Debasish Patra, the next speaker, Head of Department System Technology, Steag Energy Services, India. In his current position, he is responsible for managing several projects, provides technical support and business development related to power plant simulators, R&D, performance analysis, and optimization software. Apart from these activities, he coordinates with other departments for technical and commercial activities. He holds a BE Mechanical Engineering and an MBA in Marketing from reputed universities. With work experience of over 18 years, his areas of expertise include simulation and modeling, performance analysis, fault detection, optimization, marketing, and sales. Please welcome Flavio and Debasish on stage.
So good evening, ladies and gentlemen. And this is a joint presentation as I'm from Steag Energy Services, India, and it's 100% subsidiary of Steag Energy Services, Germany. And the presentation will be done jointly by my partner, Mr. Flavio Fernández, who is the Managing Director of DigSILENT. So basically, maybe you can say hello, and then...
Say well.
Okay.
Thank you. Yeah, and good afternoon, ladies.
So I'll present in the first slides, and then maybe Mr. Fernández can join the next presentations. So good evening to all of you again, and I know that it's very exhaustive session from the morning, and all of you must be tired with so much of, so in-depth presentations and all. Nevertheless, we'd like to take this opportunity to give some brief of use of simulations tool for improved plant and power system operations. As Madam Bhattacharya said in the morning, that probably it's a good idea to see that synergy between the power generation and the other side of the part like distribution and transmission side. So our joint presentation covers both the aspect, ma'am, in terms of software simulation tools, which is available with both of us. So before going to the next steps, I just like to make one small talk about the STEAG, because many of you might know STEAG, but I just like to tell you, it's a German-based company. It's a power IPP company in Germany, 5th largest IPP. It owns and operates about more than 11,000 megawatt. And in India also we have several O&M contracts along with engineering and other software solutions apart from simulations. So today's topic covers advantage of the simulation tools, which can help, then simulation capabilities, power plant analysis and optimization tools, because what happens then sometimes we need the tools which can help, which can cover the steady state simulation capabilities, and sometimes you need a tool which can cover the transient or dynamic simulations. Then also we have for transmission, substation simulation, which is also one of the topic today, which I'll cover. And after that, Mr. Fernández will cover the power system analysis, which could be interesting for you as well. So what are the advantages of the simulation tools? Because every software, every tool is available in the market, but we need to know that what are the advantages it can provide. So first advantage is design and feasibility studies of the plant, because our tools has capabilities that you can really design and also cover different feasibility studies. I'll come across the detailed description of the tool. And then optimization and testing of new control and operation strategies, because what's happened that any real power plant, when it takes, the commissioning takes a lot of longer period of time, you might need to recheck your control and logic. So you can use, instead of doing it in the real plant, you can use the simulation tools to test all those controls, strategies. And then you have operator training, which is also, of course, one of the important factors, especially in India, because we are expanding in very, very high rate, and a lot of new operators are coming for the operation synergies. So startup shutdown, especially, although it is a normal practice for the experienced operator, but as Madam Bhattacharya said that, the experts are going to retire. I mean, that means you need to put the new fresh blood into the operation synergies. So training simulator becomes a relevant topic today. And even for the experienced operator, the emergency scenarios which need to be covered is very important, because sometimes what happens, plant is running and without any problem. Because the automation becomes so powerful in the country today that maybe emergency scenario handling may not be the day-to-day affair. So training simulator can provide that facilities which can be trained even for the experienced operators. Power system integration analysis, which my partner Mr. Fernandez will cover. And then, of course, engineering analysis, which is also a huge area today, which can be done using the software simulation tools. For the simulation capabilities, you can see it's really quite a large spectrum. It starts from coal-fired power plant, covers subcritical, supercritical, oil-fired power plants, combined cycle power plant, solar thermal CSP, hydropower plant, substation simulations. So these are the simulation capabilities which can be covered. The two simulation tools we'll talk about. First one is called Epsilon. It's STEAG's own simulation tool, which is normally used for steady-state simulations. The Epsilon is a tool which is, today in India, it's widely used. It is used by most of the state utilities for their gap analysis, for their mapping, energy audit studies, and it is I think it's there. About 100 state utility operators has been trained, and they are using the software. ProTRAX, on the other hand, has the dynamic simulation capabilities, which covers, especially if something happens in the transient, then engineering analysis can be done, as well as the simulation tool used for the operator training simulator development. The other simulation tool we are going to talk about today is for the detailed power system simulations, which will cover by my partner from DigSILENT. The PowerFactory tool will be detail explained by him in the later part of the presentation. So Epsilon, I'll now come into the Epsilon. Epsilon Professional is a first principles thermodynamic modeling toolkit, which has a large history, quite a long history, I would say, and it is today widely used across the globe, including US, China, India, already I mentioned. Even today, there are a lot of thermodynamic modeling toolkit may be available, but what we are able to achieve today, and I can proudly say that a lot of companies, especially the OEMs, who might have their own tool, they are now replacing by our Epsilon, and that is being quite a success story for us, and we are very privileged on that. And it covers all spectrum of the power plants, starting from the thermal to gas turbine, Harzik, solar, and now we are even going to the process side, which is cement. So what is it used for? Mainly it is used for preliminary design and process optimization. So that is the tool which is very attractive to even for the OEMs, who can really design their entire plant and process before it goes into the complete manufacturing stage. Second part, which is very important, is called online monitoring and plant performance and degradation. So today we have, across the world, STEAG has supplied many online optimization systems. In India also we had now 87 actually units ordered. And of course major installations are to NTPC through BHEL. But nevertheless, we had other installations to L&T, to Calcutta Electric Supply Corporations, to Sri Cement, to Rajasthan Vidyut Nigam, and many more international projects in Southeast Asia, in Middle East, apart from Germany. So, and then of course, the third one, which is also very important in today's scenario, when PAT, perform, achieve and trade, becomes very important topic in India, where you need to do a lot of energy audit and try to see what are the gap in performance in terms of power plant. So while not going to the online, you can still do, using this thermodynamic tool, energy audit. It can be done by using the tool, or from some consultant, you can do energy audit using this offline gap analysis tool, which is proving very, very much useful in today's scenario. So it's a graphical user-based tool, if you see in the right side. So it's like in the real plant components. You can really model your entire power plant process using different components, like boiler, turbine, in the thermal power plant, and coal-fired plant, or gas turbine, Harzik, any other models. Even you can do a lot of solar. So these are some of the examples which was carried out using this tool in India. These are just specific examples we are trying to talk about. One of the study we have done, of course the project did not kick off for some other reasons, but we had done a steam injection integration study for NTPC Anta project, where 15 megawatt solar field has to be, supposed to be put in their existing 419 megawatt CCP plant. So STEAG has done the detailed feasibility study using Epsilon. Another interesting project which was done, topping of a 500 megawatt solar field into 14 megawatt waste heat recovery cement plant in Rajasthan. So these are the I would say that it is not, it is from the conventional, it is a little bit different. Then of course, as I told, for the online performance monitoring, Epsilon is a core part of the modeling. That means it provides you the entire process of the power plants based on the first principle thermodynamics. So any point of time, you get the heat mass energy balance preserved, and it also does a online data validations based on VDI 2048. That means any instrument which is not operating correct way, the Epsilon has a VDI 2048 validations which replaces the wrong measurements with the plausible measurements. Then of course it can be done, we have done an optimization of solar field in a parabolic tub plant and in feasibility of inlet chiller for CCPP or for Petronet. So it shows that, this example shows that what is the versatility of Epsilon which can be used for different industries. So now coming to the ProTRAX, it's a tool for dynamic simulation, as I said. So it has a large library of components like Epsilon, and it also has the varieties for different industries, including coal-fired, combined cycle, hydro, and it also covers the first principle modeling, object-oriented, so that it's very user-friendly. You can just drag and drop, easy to use, and it covers all engineering and training features. So not only you can use for engineering analysis, but it can be used for developing a training simulator in that way. And all the instructor functionalities, what is required for a training simulators, are available within the ProTRAX, including malfunction. So these are the standard instructor functions which are required for a typical training simulators. For example, training scenario, initial condition, run, freeze, automatic analysis, fast, slow, parameter changes, snapshot, training proficiency, which is very important to evaluate that during the process, what is the performance of a training. Instead of doing in the real plant, it could be tested in the training simulator so that you can certify that this particular trainee is now capable enough to go to the real plant to run a power plant. So these are some of the simulators we have supplied in India, varieties of simulator. Apart from the track simulator, which has more than 200 simulators has been supplied across the world. So you can see from the list that we had supplied 250 megawatt hydropower, so subcritical with different DCS. Because for a simulator, it's very important that you have to emulate or you have to provide the virtual for the exact DCS system which you have in your real plant. So from the list, it can be seen that we have most of the DCS we had covered, including ABB, Metso, Invensys, Mitsubishi, Siemens, and also for all varieties of the plant, including hydro, subcritical coal-fired, supercritical coal-fired, combined cycle, and even solar thermal. This is another interesting study which has been carried out using the dynamic simulation tool for a captive power unit, which is connected to the petrochemical complex. So the CPP is connected to the petrochemical complex, and the steam and power, both which is going to the petrochemical complex, is very important to ensure that the supply is there. So they wanted to do some emergency scenarios, and I think it's for Haldia. So the simulator, it was not a simulator project, but it's an engineering project which was carried out using the TRAX tool to exact replica of the process of the CPP as well as the control side. And boundary was from the petrochemical complex. So all the emergency scenarios was carried out and tried to see what is the battery limit of the petrochemical complex side. At the next level, we had gone now from the conventional training simulator to a little bit depth into the, you can say, transmission side. So it's a substation simulation which was being done for a project, which is used for training in switching and maintenance procedures. These are the three major parts which was covered: electrical, logic, and hard panel emulations. It consists of 161 kV, which was stepped down to 61 kV interlocks. And these are the protective devices functionality which was covered: reclosers, relays, switches, and breakers. So we had gone from the standard, from the normal process to a little bit in the substation side. You can see, and it is already available in our exhibition hall. If anybody is interested, you can visit our stall, STEAG stall in the exhibition, where demo can be shown there, that it is designed for 69 different training scenarios, which can be seen. And typical training scenarios which you could think of, like bypassing breakers, recovery from trips and faults, isolation of circuits, resetting relays, resynchronization of buses. So now I will hand over my presentation to my partner, Mr. Flavio Fernández, who will cover the power system simulation.
Okay, thank you, Mr. Patra, and thank you, everybody. Good afternoon. We have looked at the simulation from the power plant side. What I would really like to introduce now, or to present, is the simulation from the other side. So now the power plant becomes additional an element in the whole simulation model with some detail of aggregation. And then we look at the results and the challenges that we face from the power system point of view. Yeah? And this is where we have a simulator which is widely used in different countries all over Europe and also in America and Southeast Asia. So first of all, I would start here with the challenges that we have from the power system. The power system is facing many changes right now, and we have them both on the generation side as well as on the demand side. Yeah? If we look at the generation side, we have, besides the conventional large generation power plants, we have also some inflexible generation, may change from country to country. I'm talking maybe about nuclear power plants. And then we have coming more and more a variable as a non-dispatchable generation, which we cannot dispatch, we cannot control. I have heard about very ambitious plans regarding integration of wind here in India, and we have been doing in the last 10 years probably the same or similar experience also in Europe. So this is the challenge from the generation side. And we have, if we look at the demand side, on the right-hand side, you will see how the demand is also changing. So from one side, you have, on one side, you have also distributed generation, also embedded generation. Could be even during time of the day that you have your classical feeder is not a load or it's not a consumer anymore, but you are now feeding back into the system power. You may have some active demand, yeah, and active distribution networks. This is what we normally include, as we talk about smart meters, so that you can make some smart decisions and actuate at the distribution level just to optimize the network, right? So these are the constraints, and then we need to plan and to operate our transmission network, right? So in terms of planning, we expect to have a more efficient use of the transmission capacity. That means just to push back, avoid eventually network reinforcement, which are quite expensive, and then get the most of the system as it is right now. So that means we will probably get the system to operate closer to the stability limits. And this is something we need to plan and we need to analyze in detail. And the other side is the system operation, right? So optimize, we want to have an optimized operation closer to the real time. We want to increase also efficiently of system operation. And as a result of all of that, and we mentioned already, there were some sessions in the morning about that, we will have to deal with increased data volume. So we'll get more data coming into our planning tool or system operation tool like weather forecast, etc., that we want to consider in the system, right? So this is the challenge. And from the simulation point of view, what we have observed of the last year, and then the development of the software has moved into that direction, is that we get a closer integration of the simulator with your real-time, or let's say into your real-time operation. So you get more data from the real-time, from SCADA system flowing into your simulation tool. And this is what we have here on the slide. So if you look at the left-hand side, this is the classical network planning tool, right? Where, as we have done in the past, we've got different scenarios that we analyze with maximum demand, minimum demand. You have different unit commitment plans. And then you analyze your system against outages, against faults. You look at your protection. If you can clearly, let's say, selectively trip your faults. And you will also look at the dynamics. The more integration and the closer you get to the real time, this is the time. So you look here at years ahead, then you get some days, weeks ahead, and up to day ahead. Then you will need to integrate more data coming from weather forecasts, as I said before, to run your, let's say, what we call online or offline, if you want, security assessment, right? So the simulator, actually, and this is the development in the last year, has been in that direction, that you can integrate more data in the system, and then you can get or run your analysis really closer to real time. Finally, you have on real time your SCADA system, so there could be also a stronger interaction between the simulator and your SCADA or EMS system, right? This is the solution, how it will look like. So from the DigSILENT, we are a software company. We develop a power system simulator covering, as I said before, from the generation, the transmission, and the distribution side. Is an integrated tool that supports also the modeling of renewable energies, in particular wind and PV. The simulator will offer you different interfaces. This is really an important part if we say that we need to interconnect or to interact with external systems. Yeah? And beside of that, you will have multi-user environment capabilities, right? So that you have your team working capacities and ability there, and timestamp models. So your model is changing with time. So you have new assets coming in, you are decommissioning assets, and then you look for a, let's say, time range in your analysis that you want to consider, and this would be included in the model as well. So the solution that we develop is called PowerFactory. It's a power system simulator. We have different modeling capabilities and also different functions. Just to put some of the most important ones here. You can model in terms of transmission and distribution meshed and radial AC or DC system. So if you have also HVDC interconnection in the system, they have to be modeled as well. And also different phase technology. So it's not only balanced and unbalanced load, but if you have three-phase, two-phase loads, yeah, there are some countries where typical case, instead of having a three-phase transformer, you will go for three single-phase transformers in parallel, etc. So you have the phase technologies there with different with and without neutral conductors. Then you have models for conventional and non-conventional or renewable generation if you want. So it's besides the synchronous and induction machines, you have double-fed induction generator. It's typically wind generators. You have also PV system, also with an integrated power calculation, so that you can sweep the time and get what is the predicted PV or solar generation for that particular generator. Cables and overhead lines, including HVDC links, facts. You get more and more facts into the system. And it's not only the points how to model, but also how to optimize, to define the set points, so that you bring the system to operate at the optimum, right? And on the load side, of course, you have different modes for HB, MB, and LB loads. Finally, protection devices so that you can put your protection models on, and based on the different simulation, you can see if the system runs stable or not. Yeah? Important, we can run in the steady state conditions and also in the time domain, so that we need to include, we have a graphical interface for developing the dynamic models. You can develop them inside the software itself, or there are interfaces to Simulink, also MATLAB Simulink, or C++. That means if you have a manufactured model, sometimes you get a controller model from, you know, your wind turbine vendor, etc. You can integrate the code, the C++ code, into the PowerFactory simulator to get an accurate, let's say, response from the model. So this is in terms of modeling. In terms of the simulation, as said before, you can run in steady state or time domain. For time domain, you can go for the RMS simulation. This is called electromechanical simulation. You model the network just using, let's say, algebraic equation, then you use differential equations for all your controllers, right? Or you can go for a full EMT model, electromagnetic transient simulation, so that you get also differential equation for the network, right? You can combine also them. Small signal analysis to analyze the dynamic or oscillatory stability of your system. And then transmission tools to analyze how far you are operating the system from stability limits, right? And finally, as we want to operate the system at the optimum points, there are different, let's say, optimization options. Classically, is the optimal power flow, OPF, both for AC and DC calculations, so that you can, under consideration of different constraints, also outages, you can work out what is the optimal dispatch of your machines, of your power plants in the system to get, let's say, to optimize different functions like minimizing losses or maximizing the reactive power reserve, right? So this is on the transmission side. If you look at the distribution side, we need to consider also that we may have, or that we will definitely have, even in the future, more embedded generation at the distribution level, so that we need to work out different power restoration strategies under consideration of this distributed generation. We may want to look at the power quality. Yeah? Everything what is converted base generation will normally fit or inject harmonics in the system. We need to look at what is the harmonic distortion, total harmonic distortion in the different buffers, and what is the reliability of the system. So these are functions that are part of the simulator. And again, optimization tools. So for example, you want to optimize, depending on the hour of the day, if you have more PV or less PV generation, would be that instead of having the classical voltage drop, when you look at the feeder, the voltage may go up, yeah, towards the end of the feeder. So you need to work out what is the optimal tap position, for example, of your secondary transformer, so that you get throughout the day, you know, the voltage within the allowable limits, right? Working also with bidirectional power flows, tie open point optimization. This is part also of the optimization functions. And at the end of the day, if you cannot match, you know, the operational requirements, you can start looking at installing, for example, capacitor banks just to support voltage in the feeder. And then the question is, where is the optimal place? So you have an optimal capacitor placement tool, right? So this is just to give you an overview of the different functions that you will have in the simulator. And then to round up the presentation, I mentioned at the beginning, one important part could be the different interfaces. Yeah? So nowadays in a large system, we are not going to start our system or develop our simulation model from scratch, but we will have a different system already existing, and we want to embed our simulator there, right? So what you will find in case of PowerFactory are different interfaces towards DGS, GIS, yeah, Graphic Information System. We call the interface DGS, also DigSILENT for GIS, so that you can get the data across. So we got, for example, in France, the distribution company, they work like this. So the operator or the system planner, they will go to the GIS system, extract, fetch the data from here, put it in the simulator, and run the analysis, right? So the leading database in that case could be even your GIS system. And the same, of course, as we said before, this is more if we look at the transmission, for example, level, the typical application, you have a SCADA system so that you can get through an OPC interface the data as a real-time data into the simulator, and then start from there. You get like a snapshot of the system, right? And then start from there your security assessment, for example, right? So these are essential parts of the simulator, the interfaces. Yeah? We can interface really different systems, and this is how finally the solution architecture can look like. And so this is a system that we have in place with TENET, for example, is the transmission system operator in Holland, right? That you have, and this is what I want to point out here with the slide, it's not that you have the simulator in a stand-alone solution, but you integrate this in an existing environment. You have here an enterprise series bus, where you get different information coming in, right? So you are in the control room, for example, you will get some load forecasts, you will get the weather forecast data. This is coming all the time. In an interconnected system, you will get also some planned cross-border data exchange. So all this information is arriving here. You will have some staging area, and then from there, you will populate your simulator, right? So you input this data, and then you start in background the different analysis. So we have here the DAC-F is the so-called day-ahead congestion forecast. So sit in the control room, you look at the N-1. Yeah, that's okay. And then you can have also in engine mode, so different dynamic stability assessments, etc., that you run here in background in engine mode, right? So you populate the simulation model with different data coming from external sources, and then you use all this data, huge amount of data that you will need to use for the assessment of your system security, right? So this is the message in terms of the modeling. We showed the capacities, the different functions that you have, and I think the main message even regarding the integration of renewable energy is that the interfaces, the possibility of interfaces your simulator with different other external tools, this will play a key role. Yeah? So I will stop there. This is the last slide we put here for your reference, different integration cases that we have. I don't need to go through the list, just for reference. So thank you for your attention. Yeah.